Okay. The only time you can add radicals, square roots, is if the square root is exactly the same. So let's say square root of 3 plus square root of 3. We can express that as we have exactly 2 of the same square root, for example. Or we can have something like this. 3 square root of 5 minus 2 square root of 5. Okay, you just gotta remember, these are the same numbers. We don't know exactly what they are in decimal, but they're the exact same thing. So if you have 3 of the same thing minus 2 of the same thing, we only get 1 left over, right? 3 minus 2. Does that make sense? Now it gets more difficult to do this when you have something like this. Root of 8 plus root of 2. So here it looks different, right? They're different. But then you have to ask yourself, can you make it into same root? And root of 8 is root of 4 root of 2, which is 2 root 2. So you can add it now. 3 root 2. Does that make sense? Okay, what about this next one? This is 25 times by 5. And 75 is 25 times by 3. Okay, so I'm just showing a lot of work here just to make sure you understand. What's 25? That's a perfect square. It's 5 root 5 and a 5 root 3. Can we combine this? Can we? We cannot. The root's different. So I was just trying to see if you add that. This is when people do this. 10, they do this stuff. Because they forget exactly what they mean. Okay. You cannot add non-like radicals like this. Okay. So you have to stop. Try this one, please. This one you should be able to add. So they're different, right? They're different. Look, 27 and 12. Break it down like factor-wise. This is 9 times 3, right? This is 4 times 3, right? Look, right away I can see that they share a common factor of 3. So let's do this, right? 9 root 3, 4 root 3.
I got you there.
So what's 9? 3. So 3 times 3 is 9. What's 4?
2.
Do they have the exact same root? 9 over root 3 minus 2 over root 3 is?
What was the question?
Okay, so this simplifies to 7 root 3.